Alright, so we're doing the same thing as last time. We're going to solve systems that have three variables, but we are going to do it by substitution. Now, there's a typo that kind of changes everything. That first equation should equal -4. My bad. My bad. Okay. So -4. That makes a difference. Now, the first step is to choose one equation and solve for one of its variables. So which equation you want to deal with?
First and third.
First one. Just pick one equation. Okay, the first equation, which variable do you want to get by itself? X. Sounds good. So we're going to take x minus 2y plus z equals -4. And we're going to solve it for x. So what should we do with that minus 2y and the plus z?
Plus 2y minus z. Go to the other side.
Go to the other side by doing the opposite. So plus 2y and minus z. So we get that x equals 2y minus z minus 4.
Wow, lots of minuses.
Lots of minuses. Alright, now what it says below is substitute the expression for the variable you found, okay, so that's all this for for x, into each of the other two equations. So for the second equation there, instead of writing -4 times x, we'll write -4 times 2y minus z minus 4, and then we'll finish it out. So it'll be -4 times 2y minus z minus 4, close our parentheses, plus y minus 2z equals 1. Yes, the next step will be to distribute the -4 to all three terms in the parentheses. So we get -8y plus 4z plus 16, and then plus y minus 2z equals 1. Combine like terms is correct. So what do you have for your y's? -8y and positive y make -7y. I'm going to mark out each term as I go so that I know I've taken care of everything. Okay, 4z and -2z plus 2z. And then I'm going to go ahead and move my 16 to the other side.
So -15.
Yeah. So that really complicated equation we got down into just two variables equal number. Alright, let's do the same thing with the third equation. So 2x plus 2y minus z equals 10, and we're going to replace the x with our 2y minus z minus 4. So it'll be 2 times 2y minus z minus 4 instead of x.
Wait, which equation?
The last one.
2x.
Plus 2y minus z equals 10. Follow the same steps we did just a second ago. So we're going to start by distributing. So we get 4y minus 2z minus 8 plus 2y minus z equals 10.
6y minus 5z equals 18.
Ah, Levi's on a roll. So the next thing is adding like terms. So 4y and 2y make 6y. negative 2z, and negative z,
-3z.
negative 3z. I'm going to add my 8 to the other side. So that equals 18. Okay, not hard.
So easy.
That's pretty good. If you can just remember the steps, then you're doing pretty good. All right, next thing is to write those two equations we got together as a system, and then we're gonna go from there. So I've got negative 7y plus 2z equals negative 15, and 6y minus 3z equals 18. All right, and that is a system, so it gets a nice, lovely brace. So really and truly at this point, you could take these two and either use substitution or elimination. Since we're on a substitution roll, why don't we use substitution? So pick out one of those equations and we're going to solve for one variable. Which equation you want to use? The top one? Okay. So from negative 7y plus 2z equals negative 15, which variable do you want to solve for? Y? Okay. If I'm solving for y, what's the first thing I should move? The z. I'm going to subtract 2z to the other side. So negative 7y equals negative 2z minus 15. Then what? We're going to divide by negative 7. And y will equal positive 2 over 7 z, because negatives cancel, plus 15 over 7. That's not the prettiest thing, but it'll be okay.
Put the y on the other side and then subtract it or add the 15.
Yes.
Like when the z was over with the y.
Yeah, we could have done that. All right. So from this point, we take what we got for y and we plug it into the other equation, and we'll solve for z. Okay? So I'm going to say that 6 times 2 over 7z plus 15 over 7 minus 3z equals 18.
Boom.
This is kind of crazy. Okay, distribute that in. The 6. And we get, what's 6 times 2? 12 over 7z plus 6 times 15 is 90. 90 over 7 minus 3z equals 18. This is really weird. Correct. So let's see. I'm going to go ahead and make everything over 7. So what's 3 times 7? 21. Somebody figure out what 18 times 27 is. I mean 18 times 7. I don't know why I said 20. Huh? 126. Okay. So what's, when we combine the 21 over 7z, negative 21 over 7z with positive 12 over 7, what's negative 21 plus 12?
11.
Negative,
13.
negative 9 over 7z. The fractions will go away here in a second, I promise. Okay, and then say I subtract 90 over 7 to the other side.
Do we have to do fractions like this or not?
No, and if you would have picked the other one and solved for z, it wouldn't have had fractions. It just kind of depends on what you pick. Okay, so what's 126 minus 90? 36 over 7. Whew, we're almost there. What should I do with that negative 9 over 7? Multiply by the reciprocal. So negative 7 over 9. Hey, what happens to our 7s? They cancel. So I have that z equals negative 36 over 9. What's 36 divided by 9? 4. So z equals negative 4. Whew.
That's a bunch of mumbo jumbo.
I know. Y'all kind of picked the complicated one. Yeah, but the other two will come pretty easily. All right, so now take that z and where should we plug it in to figure out y? The one that says y equals. Hey, right there. Right there, right there. So, let's take, we'll have that y equals 2 over 7 times negative 4 plus 15 over 7. Okay, that's negative 8 over 7 plus 15 over 7. What's negative 8 plus 15? Positive 7? What's 7 over 7? 1. Y equals 1. Okay, now we just need x. So where do we have an x equals equation? Back up in what we did in the first step, right?
X equals 2y minus z minus 4.
Yeah, so take that x equals 2y minus z minus 4 and plug in y and z, and we will have our answer. So x equals, I don't want to do it wrong, 2 times y, which is 1, minus z, which is negative 4, minus 4. All right, simplify. So it equals 2 plus 4 minus 4. Ooh, what happens to the 4s? They go away, so what does x equal? 2. So our answer, remember, alphabetical order. Yep, 2, 1, negative 4 is our answer. Woo! It really wouldn't have been so bad except that you picked that one. If you would have picked the second one, 6, 3, and 18, those all like go into each other, right? 3 goes into both 6 and 18.
Couldn't you kind of do that as a trick, like pick the ones that go together?
Yeah, pick the ones that kind of go together. So, and then I would have solved for z because everything's divisible by 3. So that would have saved you from having fractions. But you still survived. Okay? On your homework, you've got 8 problems. The first 3, they like already have solved for variables for you, which is very handy. Okay, so go ahead and get started on it. And then if y'all decide that you want to do one together, let me know and we'll do that. But the first problem really should take you about 2 steps, maybe 3.